fall 2024 bucket courses. It's wonderful to see everyone here, all learning about brand new things, everything we need to know before we kick the bucket. I'm Sarah Smith. I am the Outreach Program Director at Grinnell College in the Office of Community Partnerships, Planning, and Research. I have the honor of partnering with the CDC here to bring bucket courses every week, and it's really great to be here. A few quick reminders. Please silence your cell phone. If you have a T-coil, please turn it on now. And we'll make sure, if time allows, for questions at the end, but we'll really make sure we have time for that. We'll come around with microphones. Please speak directly into the mic so everyone can hear you. After the program, if you are able to help, it'd be great if we can all place the chairs back on the chair dollies so we can clean up quickly and get on with the rest of our day. And so now, the main event, I don't really have a huge introduction for you, JR. I think everybody pretty much knows you. JR, retired local physician, will take us through the fascinating history of Uraniborg. So please help me welcome Dr. JR Paulson.
Let's do a little sound test in the back. We okay? All right, great. And somebody will get the lights in the front. Yeah, the lights. Yeah, we don't probably need them today. Ah, good. All right. Okay, well, welcome. I hope you'll enjoy this presentation. It's a combination of astronomy, biography, medicine, history, and it's a murder mystery. It's about the era in history in which marked the transition from medieval to modern science. However, most people know little of the giants of astronomy, let alone their fractured collaboration. Hopefully, you'll have a greater understanding and appreciation of this. And I'm trying to see here in the dark. Great appreciation and knowledge after this presentation. It's about Johannes Kepler, Tycho Brahe, and the murderer behind one of history's greatest scientific discoveries. This is a statue of Tycho and Kepler in Prague. I don't know if any of you have ever seen this here. On the left is Tycho with this big measuring apparatus there, and on your right is Kepler. Much of this presentation is based on a book. It's called Heavily Intrigued, and it's a captivating, true account of the 17th century collaboration between Johannes Kepler and Tycho Brahe that revolutionized our understanding of the universe and, they say, ended in murder. One of history's greatest geniuses, Kepler laid the foundations of modern physics with his revolutionary laws of planetary motion. But the beautiful mind was beset by demons. Born into poverty and abuse, half blinded by smallpox, he festered with rage, resentment, and a longing for worldly fame. Brahe, his mentor, was a flamboyant aristocrat who had spent 40 years mapping the heavens with unprecedented accuracy. But he refused to share his data with Kepler. When Brahe's untimely death in Prague in 1601, rumors flew across Europe that he had been murdered. But it took 20th century forensics to uncover the poison in his remains and the detective work of Joshua and Anne Lee Gillard to identify the prime suspect. For 400 years, it was believed that Tycho died of natural causes. In fact, recent forensic analysis of remains of his hair revealed that he was murdered, systematically poisoned, And all the answers as to motive, means, and opportunity point directly to one suspect. And we'll see how well you folks are on CSI investigation. If you live in Canada, Canadian CSI is like this. This guy finds something and says, "It's a boot." And the other guy says, "It's a boot what?" You got to know Canadians or live in Michigan to get that one. Anyone recognize this guy? It's Gil Grissom, the quintessential crime scene investigator. Linda and I got hooked on that series a long time ago. And before that, Quincy. So let's start with Tycho. He's the protagonist in the story. This is his portrait as the imperial mathematician of the Holy Roman Empire. They had mathematicians back there appointed by the emperor. And let's go back and look at one thing about him that you might notice that we'll talk about later. See if my little magnification thing works here. They don't show it, but his nose has got a problem because he lost part of it earlier. He came from an aristocratic old Danish family. His uncle actually wanted to raise him because his uncle had no children of his own. And so his dad said, "Yeah, I've had a bunch of kids, so you can go get raised by your uncle." But they had a good family, and so his dad, real dad saw him, but his uncle raised him. He studied Latin at age 7. He was groomed to become a lawyer and a nobleman, which people did at that time if you were growing up in the aristocracy. He entered the University of Copenhagen at age 13 to study law and philosophy. But an event came that eventually changed his life. A partial eclipse of the sun. At an impressionable age, Tycho witnessed his first solar partial eclipse. It had been predicted and occurred, quote, on time, end of quote. It struck Tycho as divine that men should know the motions of the stars so accurately that they could predict events so far in advance. He then went out as a young boy and bought the 2 astronomical tables and charts of the day. And at that day, it was the Amalgast in Latin, what he knew how to read Latin, by Ptolemy, called the Alphonsine tables, and also the Copernican tables, which predicted the positions of the planets at any time, based on some of the observations of Copernicus. At age 16, he entered the University of Leipzig to continue the study of law. However, he was overcome by his love for astronomy. The next seminal event in his life was the conjugation of Jupiter and Saturn in August of 1553 when he was 19 years of age. And he was horrified to see that the Copernican predictions were off by a few days and the Alphonsine tables by a month. So he go, "What's with this? How can you guys predict the eclipse so well, but these positions of the planets, it's ridiculous." Does anyone know what this represents? A time lapse over many days of the positions of Saturn and Jupiter in 2020. So it shows where Saturn and Jupiter were in the sky by naked eye observation on these dates. And you can see as time goes on, they get closer. So the question is, how close do they have to be called a conjugation? And I could not find the answer. Do any of you know? I just cannot find it. Nobody agrees on it. In astrology, it's anywhere between 1 and 10 degrees. And I'll have more to say about astrology later. So on December 21st, 2020, Jupiter and Saturn appeared very close together in the sky, only 1/10 of a degree apart, in a rare event called the Great Conjugation. This is a picture that I took. This was the closest conjugation of the 2 planets since July 1623. Tycho abandons law and decides that what's really needed is more comprehensive and detailed set of observations to allow for more accurate predictions. He then makes a career change, against the wishes of his parents and family, of course, abandoning law. And he sets off for Germany and searches out other amateur astronomers and formally begins to study astronomy. This is also when he almost lost his life at a duel at, check this, the University of Rostock at a professor's Christmas party. So you retired professors here, I don't know what the Christmas parties were like at Grinnell, but they were pretty rowdy back then. And so what happened is he got a chunk of his nose off. So at that time, at this party, if somebody made some comment you didn't like, what would you do? Challenge them to a duel, but not with guns, with broadswords. So these two young guys would step outside with their broadswords and have at it. And usually people didn't make it through that. Well, after they got part of his nose whacked off, said, okay, you win. Let's not continue this. So he had a prosthetic made. And they used to make them out of wax. If you were lay people, gold if you were really rich, or silver, or some people even brass, and they put that prosthesis on there. So this is a picture, a much later portrait, but you can see he's got this prosthesis. He really wasn't vain, so he usually did one out of brass and copper, which was lighter and less vain. He wasn't trying to show off gold. He then witnessed another astronomical event which would change astronomy forever. A new star, or as we know today, a supernova, suddenly appeared in the sky. So as that picture, you see that new star up there. It was in 1572 he observed this new star in the constellation of Cassiopeia and then published about it later. He then gave lectures in astronomy, University of Copenhagen, and he was convinced of his life's work. And he went to Germany and toured there and was working around with other astronomers when the King of Denmark said, hey, why don't you come back to Denmark? And King Frederick II said, hey, I'm going to fund you an observatory if you come back to Denmark. And he was given an island called the island of Ven in the Sont near Copenhagen, and there built an observatory called Uraniborg, the name for this presentation, which became the finest observatory in Europe. The King of Denmark, of course, is selfish. He wants to reward and encourage his native son, who's now world famous already, and wants to lure him back to Denmark. Well, this is the track in 1571. He publishes his findings in Prague about this new star. And because of this publication, it was eventually even named Tycho's star, as you can see in this printing. Well, this is what Tycho's star looks like today. It's much similar to what we call Messier 1, the Crab Nebula, which exploded and was seen in 1054. The Chinese described it and recorded that it was 6 times brighter than Venus and could be seen even in daylight. That's the Crab Nebula. This is an image that I took of the Crab Nebula. Although it was first observed on the 4th of July by the Chinese in 1054, think about it, it really exploded 6,500 years before that. Since it's 6,500 light years away, it took the light that long to reach Earth that we could see it. So, kind of humbling. Another seminal celestial event occurred 5 years after the supernova in 1577. An extremely bright comet appeared in the sky. Comets were big deals back then. It was also followed with great interest by Islamic astronomers and artists. Of course, the comet's going to be seen all over the world. And Islamic astronomers were also very good at that time. So what's the big deal about comets? They played a very important role in astronomy and cosmology. and not only predicting things with astrology, there were bad omens, there were good omens. There was the model of what comets were. And at that time, before that time, or at that time, it's the model of the universe, about fixed stars and about the Earth as the center. And who came up with that? It's all based on Aristotle, 300 years before the Common Era. But even as late as the 16th century, the model started by Aristotle of the universe was still based on his teachings. And basically he said the terrestrial realm was four elements. You all heard this, earth, water, air, and fire. Terrestrial realm is imperfect. It's corruptible. It's changing. And the celestial realm, single element called ether, only circular motion, and celestial realm is perfect, unchanging, and uncorruptible. The model of the universe was one like a perfect nesting spheres, like Matryoshka dolls. Dolls, if you're familiar with them, you put one doll in another and another and another. And this is what it looked like in 2 dimensions, with the planets and the Earth, of course, being at the center. Aristotle's doctrine said that comets were atmospheric. They're in our atmosphere here. They're not celestial. They're not way out there with the stars because they move and they change. Well, ipso facto, they can't be out there in the other sphere. And no one had challenged this view for at least 2,000 years. Everybody said, okay, until Tycho. Now, using the principle of parallax, anyone can clearly deduce the distance of a comet. So I can teach you all parallax if you don't already know it. So you take your finger and hold it about this far from your face, and you blink one eye, then the other. And you see how far does the object on the wall or on the screen move. Then you hold your finger out a little further, and you blink, and you see how far it moves. Of course, then if you can fold it farther out, you see how far it moves, and that can tell you distance, correct? So we have 2 eyes. It's pretty good at doing that. Well, if you look at this diagram, you see that if it's in the atmosphere, it's going to have a large parallax. So you review it from 2 places at Earth, and you're going to be looking. So I'll be looking that way at it, but if you're 500 miles that way, you're going to be looking at it this way. And then we can say, well, this is how far it is. Well, look what happens if it's out as far as the moon, the moon's orbit. It has another parallax. So the moon, viewed from different places on the Earth at the same time, will shift. But look where the comet is. It's way out past the moon, folks. So Tycho says, no. Comets are not in the earthly realm here. Another ancient astronomy person that's famous was Ptolemy. He dominated astronomy after Aristotle. He recorded his theories and findings in this large tome called the Amalgast. And he said the heavens are spherical. Earth also is spherical. The Earth is in the middle of the heavens. And the Earth has no motion, of course, at all. Now, Ptolemy's 2-dimensional model of the universe looks like this. But a 3-dimensional rendering of the model was called the armillary. It shows the celestial spheres and their relationships to one another in 3-dimensional space. And these are common. You can see these around. Now, I think it's interesting that Chinese astronomers also believed in a similar model of the heavens. The armillary, this is in the Beijing airport. So notice the similarities. So here's astronomers all over the world believing in using this as a model for the heavens. This is the news headlines in 1576. In the newspaper, Tycho gets huge national research grant. Famous scientists to set up research facilities on an island. King finds funding in the budget. The space race is on. Well, the king said, I'm going to give you your own island. and you can have a lot of money to build whatever you want. And we'll call it Uraniborg, which is translated as Castle of the Heavens, complete with observatories. For 21 years, Brahe studied the heavens from Uraniborg. It was considered the world's first large research institute. And using data that he gathered, Kepler later is able to come up with the laws of planetary motion. So where is it? Well, here it is. There's Denmark and there's Sweden. There's Copenhagen and Malmo. And this is what the island is, a pictograph of what it looks like today. And this is a map of the island where it looked like at Tycho's time. In the middle of the island, you see there this impressive grounds and structure. And this is Uraniborg. And you can see in the middle is this massive house, and I want to call it a house, a castle with all these turrets. You see around the observatory, these gardens where he grew plants for his extensive herbal and alchemic practice. So Tycho was also very world famous as a herbalist. And people would come from all over the world because he had all these medical concoctions and things to try to cure and help people with. So he had all these gardens out there, and you see the walls around it. And a closer view, also very impressive. The central structure, many areas for observation. See all those places? And this would be a typical balcony. And these are some of the instruments that he had on the balconies. And a museum dedicated to Tycho Brahe now stands on the now Swedish island of Vin. The Tycho Brahe Museum. And I think I want to put that on my bucket list. Well, Tycho had many assistants to help with observations, a lot of grad students. He designs and builds new and more accurate instruments. Scientists and dignitaries visit from all over Europe. He was known to throw many parties with his dwarf elf Jeb that would sit under the table during banquets and also could portend the future. He also had a pet elk, and the elk used to drink beer. And one time the elk tripped on the stairs, fell down, and killed himself. So imagine to be one of Tycho's parties. It'd be pretty exciting. King James of Scotland visited Uraniborg. In addition, Tycho became this alchemist, just world famous, and had lots of laboratories, not just astronomy, but down in the basement of the observatory he had all these chemistry labs. And he made repetitive and more accurate observations, bettering the previous by a factor of 10. He weds his peasant sweetheart, which those days for a nobleman was not very often done, but he didn't care. But that wasn't enough. So in 1851, he built Steinburg, translated Star Castle in English, right next to Uraniborg. He built it for a number of reasons. He needed more room and more instruments so that all his assistants could be working simultaneously. It could also be better protected from the winds. It could be covered and protect the equipment with retractable roofs that could be individually be closed or opened. Remember where this is, folks. This is up in the North Country where the weather isn't always great. His main instruments were those that would accurately measure the position of the stars and planets. This is an example of one of his many quadrants, which means it's 90 degrees. They were constructed out of special, aged, and dried oak wood. Notice that the observations were made without the use of the telescope, which wouldn't be invented and used by Galileo until 1610. So you're viewing with your naked eye. It's a picture of one of his larger quadrants, actually built into one of the walls of the observatory. But the problem, if you build it into a wall, you got to wait for the stars to come to you. You can't go to the stars. So he designed and built larger and more movable quadrants like this one that you could take and move around to where there's stars. You didn't have to wait for them to come to you. This is an example of one at the Tycho Museum. And here's a naked eyesight. We use to position the stars or planets like a finder without magnification. The underground portions of the observatory were excavated in the 1950s, and are today fitted with roofs approximating the original ones. The chambers now house a multimedia show open to the public. So you can see he had a pretty extensive operation here. There are, as we know, 360 degrees in a full circle. Circle can be further divided into 60 minutes per degree and 60 seconds per minute, or 1,296,000 seconds in a 360-degree circle. With the larger instruments, Tycho could now measure down to an accuracy of a fraction of a degree. So again, if you got a little instrument and you're trying to put a bunch of degrees on it, pretty small. You get one that's half the size of a wall, you can really make some fine measurements. And no one up to this time had ever made measurements this small. And you can measure things yourself. If you're going out and see the Big Dipper and you go, well, how many degrees is that? And you hold your fist like this at arm's length, no matter who you are, at arm's length, and it's about 10 degrees. Or you hold your index finger up at arm's length, and that covers about a degree. So if you put it over the moon, you see it covers about half the moon. The moon's about half a degree in diameter. Everything went well until Frederick died and his son Christian IV assumed the throne as King of Denmark, 1596. This portrait was made when he was much older, as he assumed rule at age 19. The new king, or probably his advisors, then reneged on the funding of Uraniborg. Said, nah, we're going to fund this anymore. And your pension. By the way, your retirement fund is just gone kaput. And the money that they had given was about 1% of the whole national budget. So that's how much Tycho was getting, 1% of the whole entire state budget. And they said, nah, we're not going to do that. And he also went after Tycho personally. It was claimed that he abused his peasant workers, was not exercised at baptism, which the church had required, and that his marriage had not been sanctified. So Tycho travels to Germany and finally to Prague. So several years after leaving Vienna, Tycho found a new patron in Rudolf II. He was even a bigger celebrity because he was the emperor of the Holy Roman Empire. And he was given a healthy stipend there and challenged with completing and publishing his work. He was given the use of the castle Benátky, about 40 kilometers north of Prague. And this is a picture of that castle. And this is a picture of Rudolph. A portrait as for Temnus, the Roman god of the seasons. And you could probably get by this portrait that he was a little clearly mentally unstable. But much like the northern Medici, he, in his patronage, greatly funded both the arts and the science, including Tycho. So Tycho could either go in there and say, hey, why don't you give me some, science, art, yeah, no problem. So he, later, now he's at Prague, and Kepler is an up-and-coming astronomer who we're going to talk more detail about later, and after the break. And he's to help him complete these mathematical tables that he's been working on for 20 years. I need some help. I need a mathematician around here. Kepler seizes this away to get the data because he's trying to complete his theories on celestial mechanics, but he doesn't have any data. So who's got the data? Tycho's got the data. So he works with Tycho for over 1.5 years with Brahe until his death. However, Tycho only lets Kepler see and work on a small part of the enormous collection and logs of his observations. Okay, a little bit about Copernicus, and then we'll take a break. We now need to turn to Copernicus and his model of the universe. Besides the astronomical models of Aristotle and Ptolemy, there was a new and different model proposed by Copernicus. And of course, his was the sun-centered. We all know him for his revolutionary cosmology, but he was also a polymath. I like this: a practicing physician, mathematician, engineer, and even wrote several significant economic treatises that still influence economic theory today. The publishing in 1543, just after his death, on the revolutions of the celestial spheres was a major event in the history of science. I'll have more to say about his death later. And he's regarded as one of the central figures of the so-called scientific revolution. And maintained that the planets, however, orbits were circular. But, of course, looks what's at the center of the solar system. The sun now, not the Earth. However, even though he got the heliocentric solar system model right, his model, like the Ptolemaic, had major problems predicting the orbits of the planets, especially Mars. It also begged the question, what's on the other side of the sphere of stars? Okay, you got the star sphere, well, what's on the other side of that? And Copernicus didn't say. On October 1517, Martin Luther nailed 95 theses on the castle church door at Wittenberg, marking the beginning of the Reformation. There's generally more church tolerance in the Protestant-controlled countries towards scientists and their theories. But as we see with Giordano Bruno, 1600, and later with Galileo, 1610, there was little tolerance given by the Catholic Church. How many of you know the story of Giordano Bruno? Anybody? This huge statue stands in the center of Rome, not far from the Pantheon. He's most remembered by his death, having been burned at the stake by the Catholic Inquisition, accused of heresy. Well, what did he believe? Today, 17th February, 1600, Giordano Bruno was charged with heresy by the Catholic Church for proposing that the stars are distant suns, that these suns could have planets of their own, that these planets could possibly harbor life, and that the communion can't possibly transform into the body and blood of Christ. And for these, he was died and burned at the stake and became the first martyr of science. And one of his quotes that I remember and like to, that's quite apropos today, truth does not change because it is or is not believed by the majority of the people. So it's just true today as it was in the 1600s. So back to Tycho. The model he created was a hybrid one. So Tycho had his own model. And if you look at this, you go like, well, wait a minute. This model, the sun and the moon still revolve around the Earth, but the other planets all revolve around the sun. And you go like, that's having your cake and eating it too. Wait a minute. This is kind of a hybrid model. So this is what Tycho came up with. But now we have three models of the solar system, which is right. Ptolemy and Aristotle's model, Copernicus model, or Tycho's hybrid model. And I think, Sarah, is now a good time to take a break? Or should we want to wait for about 5 more minutes? Okay, great. So let's change gears and go to Kepler, the man who had the greatest interest in Tycho's work. Here's a portrait of Kepler as the imperial mathematician. He succeeded Tycho as the imperial mathematician for the Holy Roman Emperor. So what was interesting about Kepler, he just didn't want to observe, but he wanted to explain what was going on. He had training to be a priest or a minister. And he turned to mathematics and said, the secret to this is mathematics. I'm going to figure all this out by mathematics. Well, guess what? He had the same childhood experience as Tycho did. So when he was 6, his mother pointed out a comet, the same comet, by the way, in the night sky. When he was 9, his father took him out under the stars to observe a lunar eclipse. And these events made a wide impression on him and turned him toward a life oriented to the study of astronomy, not the ministry. So a brief slide of Kepler. He's born in Germany, about 25 years younger than Tycho. He had a horrible, abusive childhood. He contracted smallpox at age 3, which scarred his eyes, though he's not going to be a good observer. He was put in many schools where his teachers recognized his potential. He studied theology but excelled in math and eventually became a math teacher. He did not play well with others. He kept a diary and later incorporated it into a book titled Self-Analysis. He was always working on how to reconcile astronomy and theology. How can he get his religious beliefs and his scientific to jive together? And he did not ask the why questions, but the how questions. And he thought he'd be able to discover the laws of God, which he felt were clearly geometric and mathematical. This is the famous picture I've showed before, Ancient of Days by William Blake. It shows God with a compass measuring the earth. This picture also reflects Kepler's personal life. Kepler tried to show the relationships of the platonic solids to the orbits of the planets. He composed a large portion of his book, Harmonics Mundi. And so you have these 5 platonic solids with all the faces, the angles being all the same, and all the faces the same size. And he was really trying to relate this to the orbits of the planets. And he tried to show that all the platonic solids could be nested inside one another, and that posited the planets orbited in the same ratios. So I think that's kind of cool. You got a sphere, and then inside that, a cube, and inside that, all the tetrahedrons, and they nest just really nicely. Kepler's first work was the first published in defense of the Copernican system. So Kepler says, I think Copernicus has got this right. For your musical folks, the thought that the planets made musical tones as they orbited was a common belief in the Middle Ages. They thought, you can hear those planets going around, and these are the notes that they make. Okay, one more topic, and then we'll take a break. But how do we explain the movements and the positions of Mars? It reverses its direction in the sky and traces a loop. So you go, wait a minute, Mars is going like this, then all of a sudden it goes whoop, backwards, and it does this loop-de-loop thing. And when you do over time, it looks like that. And you go, how do you explain this? This isn't working too well. And this is why Tycho's observations were so important in trying to answer this question. His data over almost 20 years was both accurate and consistent. So you see all these years, and you got all these data, and he plots this all out. And this is the data that is going to change science and history forever. And his data, almost 20 years, was accurate and consistent. He would throw out bad data or big outliers and repeat it and repeat it and repeat it. We know now how to simply explain it. Well, how does Mars goes like that? Well, we know with the correct model of the solar system, the Earth's orbit, Mars is outside us, and we go a little faster, we go by it. So if you look at this model, you can see, well, Mars is going to look like it's over there when the Earth is there, but let's wait a month. And Mars is coming up in a couple months, by the way, to be the closest that it'll be, what we call it opposition, in a couple months. And so we will witness that. If you're watching, it'll do that. So the question is how to get Tycho's data. He corresponds with Tycho many times, but Brahe was not going to give it out to him. He had already been plagiarized once and said, not again. So I think this is a good time. So then, after break, we're going to talk about astrology. And then, I think I'm setting this up. He's got the data. He wants it. How's he going to get it? Yeah, so I think the second part is going to be the more CSI part. Okay, so have a good break, and we'll see you back in a few minutes.
To now hear more about the CSI part of your presentation. JR.
Okay, thank you. We still okay in the back on hearing? Thumbs up, good. How to get Tycho's data. So again, Tycho's not giving this out very well. We're going to talk about astrology for a little bit, because at this point we need to briefly say some things about it. Astronomy and astrology were Siamese twins at this time, with astrology felt to be the more important and practical. Who cares about all this movement in the planets? I want to know is what's my fortune, what's my personality. The water bearer Aquarius, Note, Saturn now is in the constellation of Aquarius, which for some of you in here, we remember and can start singing The Fifth Dimension, the Age of Aquarius. Anybody know that song? All right. So anyway, this is one of my favorite songs too. Astrology as a way of predicting the future goes way back thousands of years. The famous Oracle at Delphi, who some of you have heard about, practiced from 1400 before the Common Age to 381 AD. So that's a long time of being a fortune teller. Most astrology is based on the 12 signs or constellations of the zodiac. It focuses on the signs of the zodiac and what celestial bodies are in which, quote, houses or constellations. The Chinese also divided the sky into 12 zodiac signs. In addition, in Chinese astrology, each sign also designates a birth year. And with a birth year, a personality type. Ever eat at a Chinese restaurant? Of course. And read the placemats? And you find out, let's see, okay, I was born in 39, or, you're blah, blah, blah. Both Brahe and Kepler made and were paid well for astrological predictions over their entire lives. So they made more money probably doing astrology than they're trying to do astronomy. It's actually pretty complicated stuff. Not just anybody can make these observations and later put them into predictions. So let's look at this slide briefly. Kepler's criteria for the judgment of his birth. Aquarius is ascendant. Placidius houses. I don't know what half this stuff means. Grand conjugation of the first house of Pisces. The south node. You can just look at Mercury in Virgo, the sun in Libra, Mars in Apogee, Venus in Scorpio, trine Saturn, north node in 10th house. I mean, like, geez. Nobody's just going to come up with this on a placemat. Kepler's father's personality, which was horrible, was based, as was his, on positions of the stars and the planets. Kepler remembers his brutal father, who used to beat him. Saturn in trine with Mars brought about a wicked man, abrupt, contentious, and led to an evil death. Venus and Mercury increased the malice. Jupiter in fiery dissension made him a poor man. Saturn in the 7th house led him to study gunnery. He blew a gun when he was loading explosives, blew up in his face. But this is all astrological prediction. At this time, world history was believed that events in the sky directly affected events on Earth. Rulers almost always consulted with their court astrologer to determine when to go to war, when to expect a famine, and when to anticipate threats on their own lives. This is rulers all across the world at this time. So here's a woodcut, 1577, links two lunar eclipses with the destruction at the hands of the Turks. Flash forward to the 21st century. Astrology is alive and well, even in the present digital age. So you don't have to do this. You can go online. You can go to astrology, fill all this in, and get a prediction. Now let's change topics and move into the CSI part of the presentation. Death. Tycho died, as you can see, in 1601 in Prague, 11 days after suddenly becoming very ill at a banquet. Toward the end of his illness, he said to have told Kepler in Latin, "Let me not seem to have died in vain." 400 years, the general belief was that he had strained his bladder. It had been said that to leave a banquet before it concluded would be the height of bad manners. And so he remained, and his bladder, stretched to its limit, developed an infection which later killed him. This theory was supported by Kepler's first-hand account. Holding his urine longer than was his habit, Brahe remained seated. Although he drank a little overgenerously, he was a good drinker, and experienced pressure on his bladder, he felt less concerned for the state of his health than etiquette. And by the time he got home, he couldn't pee. Finally, with the most excruciating pain, he barely passed some urine, but yet it was blocked. Uninterrupted insomnia followed, fever, and little by little delirium. His poor condition was made worse by his way of eating, from which he could not be deterred. About 10 days later, on the 24th, when his delirium had subsided for a few hours, and amid the prayers and tears and efforts of his family to console him, his strength failed and he passed away very peacefully. Remember, he's 54. Now, the description of his death was described at his funeral oration by Gesenius, which was a close friend and personal physician. So here's a doctor at his funeral saying, well, this is what happened at the banquet, and he didn't pee, and he got this, and he died of that. And there's another physician made a comment on it. So people are commenting medically what's going on there. And at the bottom, Gassendi, another famous person at the time, writes that when he noticed he was coming near death, he expressed a wish that his lifetime's work would honor the Lord, and he gave his sons and his nephews a task, not to let anything or any of it get lost, and they should trust in the help of the empire. So basically he says, I'm willing my debt to my heirs, to my sons, and you give it to the emperor and continue the work. On looking at the signs and symptoms, it appears that Tycho probably died from kidney failure. And there are two little medical talk here. There are two types of renal failure, acute and chronic. Chronic is unlikely. It develops over years. It's also totally unlikely that he died from a ruptured bladder, as that's extremely rare occurrence, almost always associated with trauma to the bladder. Your bladder, because you can't pee, just doesn't suddenly blow up. So causes of acute renal failure. Pre-renal, you get a drop in blood pressure, you go into shock. Intrarenal, something happens inside the kidney that damages it. Drugs, inflammation, toxins, or reduced blood supply. Or post-renal, there's a block that pee can't get out. Why can't it get out? Maybe you got a big kidney stone, maybe you got a large prostate or a bladder tumor. If it was due to a blockage, his bladder would have been extremely distended, as many of us in this room may know, and easily diagnosed. On the other hand, sepsis from a urinary infection would have been more likely. So they said, well, his bladder got too big and was going to explode. Well, catheterization for urinary stones was uncomfortable, but not an uncommon procedure. They didn't know how to cath people back then. They could easily make that diagnosis. And his personal doctor had written tracts on how to catheterize with different catheters, what to use. So his bladder blew up. I'm not buying. On the night before his death, Brahe sang hymns and prayed with his family. He made a special point again of bequeathing his observations and logs and instruments, his most valuable possessions, to his heirs. And about his funeral, they had all these funeral procession going through Prague on November 4th, Damas flag, and they finally lay him to rest. And he died around 9 o'clock the following morning. Tycho is buried in I pronounce that, church in Prague. His tombstone is written on it. It means, I'd like this quote also, neither power nor wealth, only art and science will endure. Some of our leaders ought to think about that. This was the same quote that was affixed at the entrance to Uraniborg, or his Castle of the Stars. So he was not a vain person. His tomb is in the Church of Our Lady before Tin in the old town of Prague. Anyone ever been there? For centuries, the often spoken question was, on many people's mind was his death a murder? But wasn't this a very cold case? So over 400 years after the death of the Danish astronomer Tycho Brahe, scientists in Prague are preparing to exhume his body. He was Europe's most renowned scholar. Was he poisoned with mercury? The Danish scholar claims to have decoded the murderer's diary. And the truth didn't begin to emerge until 1991. The Prague National Museum, which Brahe's mustache, remember that big mustache he had? In its collection, took a few of those hairs to Denmark. And lab tests revealed, they gave it to scientists at Lund University in Sweden and said, hey, why don't you just check out this mustache hair? And revealed mercury levels more than 100 times above normal. And here's a picture of Tycho with his mustache. So they gave him this one hair. 5 years later, physicists at the University of Lund presented the results of another study, this time using a photon microprobe. The famous scholar had swallowed the heavy metal all at once about 13 hours before his death. This is a proton-induced X-ray emissions machine. It shows the chemical structure of sample. And the second one is an image. You can see this one 5 years later. They got a better machine now. And this one will take a laser and go down the hair, not just analyze the hair, but go down different spots in the hair and do analysis, different spots on the hair, which of course represents different time, right? And that could be accurate to hours. So you can see these different readings that they have on here. And other metals besides mercury, like iron, zinc, and calcium, they also could measure that. So this is a sign of iron, zinc, and mercury. Well, Paulson's graph shows this. And I think you can see that his death is 0. And this graph goes out about 3 or 4 days. And you see the big, huge spike there, about 13 hours before. Gee, that's mercury. And before that, you see a little spike, iron and calcium. And there's some out farther, but even way back to 3 days, there's not much of anything. Now we have forensic evidence of what was in Tycho's body and when. Now, how do we explain it? Well, this is the theory. They say, well, the earlier first study in the hair showed that he had a fair amount of it in his body. But, as you can see on the graph there, but over a bunch of days, it kind of almost went away. And then, all of a sudden, there's the big spike, and he dies within a day. Well, the layperson is going to say, well, duh, somebody's trying to poison him up here earlier, banquet time, right? But he doesn't get enough in him to do him in. And he gets better. Body recuperates. And then all of a sudden he gets this big thing, and that's it. So the first episode, poison attack, supposedly an acute illness, he's sick, he's bad. Even if he's got an infection without antibiotics, he gets better because he gets consciousness and he's getting better. The symptoms fade, and then all of a sudden, so that's the hypothesis for the forensics. So, who's a murderer? Who had motive? Revenge. They want his data. Is it for money? Who had the means? Who had the knowledge of poisoning? Who had the opportunity? Limited to close friends or relatives in his lab. Was it suicidal, accidental? He was an alchemist. Remember, he's working down in the lab all the time. Was he poisoned? The U.S. expert Joshua Gilder, who wrote the book, believes an assassin used mercuric chloride, which he dripped into Brahe's glass. A few drops would have been fatal. So, again, that's one of the themes of the book. So the question is, Kepler the killer? He certainly had the motive. He wanted this data. He already knew some potion making. His mother was a potion maker, and he was very familiar with Tycho's alchemic lab. He worked in it. He knew where the chemicals were. He was the only assistant working with the astronomer at the time of his death. He got sick. They said, the rest of you guys can all go home because we don't know, your leaders may not make it. And he was present at the house and no doubt could see Tycho at any time and was with him. His own words describe his own character in his autobiographical book, Self-Analysis. In describing himself, Kepler says, he's unlikely, he always spoke in the third, he is unlikely to assail, to insult, to challenge every man. There is rage and eagerness for trickery, watchfulness, spontaneous and sudden assaults, and perhaps good luck is not completely lacking. He also portrays himself with deception, envy, jealousy, and has no problem with lying, lacking a moral baseline. This is what he's saying about himself. Tycho had wanted to complete the major work within 2 years, but Kepler saw himself as someone thwarted and by a man for whom he was unable to contain his expressions of contempt. There's lots of quotes about disagreements he had with Tycho. Anything less than the immediate possession of that riches that he coveted was almost too much to bear. Although the logs were willed to the family, Kepler took the massive tomes of data with him after the funeral. So while everybody's doing the funeral preparations, hey, what happened to those logs? Oh, they disappeared. Well, guess who got it? Kepler came in and took them. Even after the family sued and had it legally given back after many months, he kept the Mars portfolio. They probably didn't even notice that. Well, Mars was the most important. It was the most important one because it had the data, the most variations in all the planets to its more elliptical orbit. So what Kepler thought would take 8 days ended up taking several years for publication. So the suspects, it's been argued that Kepler had the means, motive, and opportunity. More recently, it was suggested that the murder could have been by this distant cousin, this Count Erik Brahe, on the orders of the King of Denmark, the new king of Christian, who said, well, he was having an affair with his mother. Like, talk about conspiracy theory. You know, oh, yeah, this guy came over from them, and, you know, he had him assassinated by doing this. Well, anyways, not everyone believes that Brahe was killed. Administrators of his estate question whether mercury was even sufficient potent to cause his death. Others believe it was an accident. Brahe was an alchemist who made miracle drugs, and some believe may have killed himself by accident. Brahe knew how to use this stuff. He was, and make it. What do you think, given the evidence so far? If you were on a jury or a grand jury, how would you vote? First, was there enough evidence for a crime of murder, or did he die a natural death? Second, if it was determined to be murdered by poisoning, did Kepler do it? So let's take a vote just for fun. So how many think what you've heard so far think that he got murdered? Raise your hand. Okay. And if he got murdered, how many of you, or you can vote for twice, how many think, well, if he got murdered, I'm pretty suspicious about Kepler? Raise your hand. Okay. Very good. To resolve this mystery once and for all, Brahe's grave will be exhumed. This year, which will be 2010, a group of conservators, chemists, and physicians to open the vault in Prague's Sign Church in Wenceslas Square and perform a forensic analysis again on the body. All eyes are in his musty vault, and they got TV broadcasters there interested. This is a big deal. And the Danes are kind of worried because they go like, yeah, well, what if we find that the Danish king, this Erik guy, did it? That's not going to let us look very good because we love our king Christian. So there's politics involved. So what will we find out? And the expert plan, they said, let's do a computer CT of the skeleton and get a bunch of his bone material, which, of course, they did before. This was all based on a mustache here. And this Jens Velev is going to lead the group. It's waiting for approval. Well, but most experts think they know the results. They claimed existing test data already shows that Brahe was murdered. But this is CSI. We got to know for sure. So here's a picture of them in church uncovering his grave, and they did do that. And they took the clothes, bones, and other remains here they have in there are analyzed. What was their conclusion? 2 years after Tycho Brahe was exhumed from his grave in Prague, chemical analysis of his corpse showed that mercury poisoning did not kill the prolific 16th century astronomy. The results should be put to bed rumors that Brahe was murdered when he most likely died of a burst bladder. Well, wait a minute. You know, I thought I saw this spike in mercury and you know, and oh, burst bladder. Well, I'm not buying it. This is the research leader examining the remains of Tycho Brahe. So what other things did they find? Chemical analysis of the bones indicated that Tycho was not exposed to an abnormally high mercury in the last 5 to 10 years of his life. So it wasn't while he was working around the lab and he just got too much, poisoning from that. Okay. Well, I just showed you that this was maybe an acute thing. Tests on his beard hair showed that the mercury concentration in his body were not high enough to have killed him, they said. Well, I'll talk about that. Different people's bodies are responsive to different amounts of poison. One of my patients I remember well in my last years of practice was in her early 40s and came into the office, and we diagnosed her with acute kidney failure about this far from death from taking a few ibuprofen every day. So she didn't have to take mercury or something else to, quote, kill her kidneys. So different people have different susceptibilities. And we saw that high speak, and maybe that Tycho's kidneys didn't like that. So just because, this is the level that kills people, it can be different for different people. And the nose piece they found, and they said, we thought that was silver. They found that was brass. No big deal. But they didn't find the body contained a whole bunch of gold content, between 20 and 100 times higher than a normal person, showing that he was excessively exposed to gold in the last couple of months of his life. The study says, big deal. Gold is inert. It doesn't kill you. It doesn't do stuff. A lot of people work around gold, and we used to give gold therapy for arthritis. We'd actually inject gold into people in the old days. So forget the gold stuff. Well, then what did he die of? The results should be put to bed a rumor that he was murdered when he said dispersed bladder. We just kind of debunked that, but I'm not buying that. Have attended many autopsies and treated many patients with the above diseases. I know they usually don't die the way Tycho did. Because others said, he probably died from a blocked prostate secondary to benign prostatic hypertrophy. Well, trust me, there's a lot of people in this room, and me included, and others have that and have bad bladders, and you don't just follow what he did. And you get catheterized if you can't pee. Affection of the kidney or bladder stone. They didn't find any bladder stones when they did an autopsy on him that was in there blocking stuff up. Or prostate cancer. I've taken care of many patients who've died of prostate cancer, and you don't go like Brahe, you're a healthy 54-year-old, and then all of a sudden you go to a dinner party, and then, 10 days later, you're dead. So, anyways. I guess we'll have to conclude that we really don't know for certain what killed Tycho, and probably never will. Well, his contributions to astronomy were enormous. He revolutionized instrumentation. He took readings at different times, not just at opposition or quadrature or certain places, but throughout the orbits. And he got down to an accuracy of 2 arc minutes, and some of them less than that, which is, those of us that know astronomy, this is getting much better accuracy without the telescope. So let's now turn over to Kepler. What happened to him? But his story obviously continues. Well, a new supernova appears. Gee, these things are popping up all over in 1602. He publishes the description of it a couple years later, 1604. And that's his publication about this new supernova. But the old charts and tables were still in use. Nobody's still using these old tables. They were inadequate. So Brahe's dying wish was that these tables would get completed. Well, Kepler did get it completed in 1624. So think about that. It's 23 years later, after he's got the data, he puts it together and finally publishes it with this new set of tables. And this is what the cover for that, the title cover. He explains why the model of circular orbits by Copernicus, Ptolemy, and Tycho were all wrong. He discovers and states the 3 laws of planetary motion. Number 1, planetary orbits are ellipses with the sun at one focus. 2, for any planet, a line joining the planet as it moves and the sun sweeps out equal areas in the orbital plane in equal times, which to layman's terms, it kind of goes faster when it's closer to the sun and goes slower when it's farther away from the sun. And you want, how long does it take the planet to go around the sun? Well, he came up with a mathematical formula for that. The square of the orbital periods of the planets are proportional to the cubes of the orbital sizes, the semi-major axis. So he's got this all Kepler figured out. So you see, the orbits of a planet is elliptical. And these other guys go, what's an orbit? What's a planet? What's elliptical? Besides his Platonic theories, the last section of the book offers his third law on planetary motions. Now, this is really important. Kepler also notices that the Galilean or Jupiter satellites also obey his law. So wait a minute, he's got a planet now with moons going around it. Well, in science, going around the sun is one, but if you can prove the same thing with another, implies that Kepler's third law was a general principle. So when you measure Io, Europa, Ganymede, and Callisto, and plot their plots and their orbits, you find it follows Kepler's laws. So it completely vindicated his theory. Now, it's interesting, Galileo himself refused to accept Kepler's ideas. Remember, he's coming right after this now. And he still thinks the planetary orbit's got to be circular. He's buying the Earth is not the center of the universe, but he's not buying the circular stuff. And they even corresponded, just a letter from Galileo to Kepler. And he's telling Kepler, yeah, I've supported this Copernican theory for years. Well, he had to watch what he said about it. So Kepler, geometry is unique and eternal reflection from the mind of God. That mankind shares it is because man is an image of God. And that's a quote from Kepler. Reflects both his Platonic and his theologic beliefs. And shortly before his death, Kepler composed the following epitaph, what he wanted to have on his gravestone. I used to measure the heavens, now I shall measure the shadows of the earth. Although my soul was from heaven, the shadow of my body lies here. The Kepler Space Telescope was a space telescope launched by NASA in 2009 to discover Earth-sized planets, orbiting other stars. Of course, it was named after Kepler. It was launched into Earth-trailing heliocentric orbit, and as of June 2023, last year, it had discovered 2,778 exoplanets. Bruno would now feel vindicated. Remember the claim he made when he was burned? There may be other stars with other planets. Kepler also has a 20-mile in diameter crater on the moon named for him. And the crater Tycho, on the other hand, is very impressive. That's the big one that you see there with all the rays going out of it. It just happened over 100 million years ago, which is pretty recent on the moon. It's 53 miles across and has a mile-high central peak that you can see in it. So Tycho Brahe painted a portrait here of him around 1600, one of the great astronomers of the Renaissance. So, let's consider another heavenly CSI case before we close and ask for questions. Mystery. Where's the body of another famous astronomer, Copernicus, buried? Remember we talk about Copernicus? So this is a brief story of another astronomer. And again, a single hair. Toward the close of 1542, he died well before Kepler and Tycho. He had a stroke, and he died at the age of 70 in 1543. Legend said he was awake at the final moments of his life, and they showed this book that he just said about the revolution of the spheres, and looked at it, and this is my life work, and then he just died peacefully, which is probably true. So, the strange story of the grave of Copernicus. Upon his death, in Fromberg, Poland, he was buried in the local cathedral. But over the subsequent centuries, the location of his grave was lost to history. And they said, well, we'd like to find Copernicus' grave. And they looked around, they couldn't find it. And efforts to locate them in 1802, 1909, and 39, they couldn't come up at all with it. Napoleon, by the way, he even tried to find his Copernicus' grave because Napoleon really thought a lot of Copernicus. So here's the emperor going around looking for his grave and can't find it. So these folks said, well, we really like to find it. This is the plaque and the epitaph that's in the church on the wall. And this is Fromberg Cathedral. So in 2005, a group of Polish archaeologists took up the search. So they're looking around and they're trying to figure out, and they said, well, he's probably born because he's probably buried because he was like a bigwig in the church, and they probably would have buried somewhere in the altar, so let's look under the floor and all around the altar, and they find, 13 skeletons are found there, but they're incomplete, and some of them belong to a male aged between 60 and 70, which he was 70 when he died, and that is the closest match. Well, what are you going to do about that, CSI? Well, in 2006, the next year, a new source of DNA reference, go back. Jeez, wait a minute. How did I get to that? Excuse me, let's get back. Okay, here we go. Okay, so they got these skeletons, and they think this one could be Copernicus. Okay, so here's where I want to be. So in 2006, a new source of DNA was found. An astronomical reference book used by Copernicus for many years was found to contain a hair among its pages. Well, where did they find the book? It had been taken to Sweden as war booty following the Swedish invasion of Poland in the mid-17th century. And it's currently in the possession of the museum in Uppsala University. So here in Uppsala University, they got this book that was stolen, and it was probably Copernicus's. So they examine the book and check it out, and they find there's a hair there. And Copernicus owned it, and they figure, it's probably one of Copernicus's hairs. Well, they decided this could be a genetic reference. So they do a genetic comparison with the teeth and the bones that they find in the tomb, and voila, matches. So now they're able to find from this one hair that this is indeed what's the skeleton of Copernicus. And it showcases the depth and sophistication of modern scientific methods in corroborating historical data. So, in conclusion, was Tycho murdered? And if so, who done it? We don't know yet. You decide, but it's something to think about. And if you decide to commit a crime, just be sure not to leave any hairs behind. And if you're at an event and nature calls, I suggest you excuse yourself and go to the bathroom. So, with that, thank you for your time and attention, and we'll open to see if anybody's got any questions. So.
The evidence of the evidence of mercury in that hair is quite impressive, but it's an old legend in chemistry about Hatter's disease, and Hatter's the Mad Hatter of myth is related to hat makers, right? And hat makers were alleged to be subject to disease from mercury poisoning, and their main symptom is madness, but that doesn't appear to have any connection with what happened to Tycho.
Yeah, so let's talk about mercury. Mercury has been used for thousands of years as a treatment. Those of you know, or may know, people used to take mercury, the quicksilver, and if you were really constipated, you'd drink quicksilver, mercury. Well, boy, that's going to push stuff out. But mercury has been around and used in many preparations and different things for hundreds and thousands of years. The word in, I'm trying to think of it. Right. And so I wanted to take off on some things that you said. That one is... this has been used for a long time. So I'm trying to think of the word in Hindu, and I think it's called Raja Sudi, which is the word for alchemy in Hindu. That means knowledge of mercury. So if you were anybody that was doing herbal stuff, you do that. And it was used in many different things. It could be used topically. Remember the nursery rhyme, rub-a-dub-dub, 3 men in a tub? The baker, the butcher, the baker, the candlestick maker, they're all off to sea. Well, that refers to getting treated for syphilis. Mercury was used for treat syphilis. You'd be in these big vats, they'd heat them up, you'd breathe in all this stuff in these tubs. So that's a reference to that. How many, well, in this group, how many of you had mercurochrome put on you when you were a little kid and had a cut? Well, mercury. So mercury, it depends on what form it's at. If it's Hg with 2 chlorides or 1, or it's at a sulfate. And all this was very, very well known to Brahe. And I brought a little thing for you. Brahe's recipe for his mercuric drug. And this is from Brahe himself in the 1600. He wrote, and it's got all the chemical formulas of how you sublimate it and you turn this into that, and it's going to be interesting for a chemist to look at. So you can get into the mercury stuff even more. So it was used for syphilis. Brahe used it to treat elephantiasis, treat scabies topically. And but he, again, the whole thing in herbal medicine is to get the right amount. And so a small amount of mercury is a diuretic, mercuric chloride is a diuretic, but too much will shut your kidneys down. So it's getting the right amount. And he was pretty savvy in doing that. So great question.
I have a question
Yeah.
about again, same line about the hair. Is there any environmental factors that could have affected the mercury levels that were found in his mustache? Either
Yes.
grave, handling right after he passed away. Is there anything like that that could have affected those results?
Absolutely. One of the hypotheses was when they did it, they found it more on the outside of the hair than the inside. Well, that means you're breathing around so in your lab, and so you would pick up it from the outside. But when I use that, I'm going, well, wait a minute, he's sick in bed. You know, he's almost dying. And that peak, he's not down in his lab. You see what I'm saying? I can see how it explains some of the long stuff, but I'm still going to like wonder, well, how did that big blip get there? And if you looked at the thing, you see there was a big thing of calcium also a few hours before. Well, he doesn't say, here, take this. So whoever, if there was a poisoning, you know, you'd say, well, here's some milk. It'll settle your stomach, and you use the milk and the calcium. The milk would show up as a big peak to disguise the taste of the mercury. And the iron, to get more technical, one of his things that he did was supplement it with iron filings, and so that there's some could be traces of iron there. So even the milk of how he got it is kind of it's a big jigsaw puzzle.
I can't resist making a comment about the Kepler laws, which are obviously very meticulous observation, and they're wonderful, but they're also sort of mysterious because one doesn't know why that's the case. But I remember in teaching calculus, if you just assume the law of universal gravitation, all the laws come out very, very quickly. So this empirical observation comes right out of universal gravitation. It's very easy.
Arnie's completely right. And so one of the histories of science is you're built on the shoulders of other people. So here Newton coming around, and he's got, you know, like, wow, that's a slam dunk. But Newton couldn't have come up with his gravitation unless you had the laws that. You couldn't derive that from the circular stuff. So again, it made it easy for Newton to come up with that. And those of you know, eventually you find out there's a way that's accurate for pretty much close, but what about some of the planets of Mercury, you know? It doesn't quite follow that. Just when you think you got the slam dunk and everything, and you go, well, yeah, but yeah, that's just bad data. No, good scientists don't ignore bad data. They gotta explain why Mercury orbit doesn't quite go like it should. Well, guess who hopped on that? Einstein. And said, well, you guys are missing something else. And Einstein's theories of relativity kind of even more corrected Kepler. So it keeps going up like that. So great question.
One more round of applause, please, for
Well,
Dr. J.R.
thank
Paulson.
you very much.
Thank you very much. Thank you.
You're
Thank you.
welcome.
I look forward to seeing everyone again next week. Next week, we welcome Chris Jones. He is the associate professor and special collections librarian and archivist of the college. He named his speech his talk next week. A physician, a scholar, and an inventor walked into a library. The collections behind Grinnell College's rare book collection. So I had a more serious title, and I think it's great that he made it, kind of into a joke. So I'm really excited to hear from Chris next week. He has a great presentation about Grinnell College's archives, some of the rare books that we have over there. I look forward to seeing everyone next week. A real quick plug. Remember, this is a very big weekend for Grinnell College. Friday morning at 10 o'clock, we welcome Mrs. Edith Renfro-Smith back to Grinnell. She is on her way. She's very excited to be back here again in her hometown at 110. We will have a parade that will go down Broad Street and then end at Grinnell College. Please feel free to line the streets and welcome Mrs. Edith Renfro-Smith as she arrives officially in Grinnell and on to the Grinnell College campus. Then Friday night, we're going to have a concert and dessert in Central Park, along with a live band that everyone's welcome to attend. It's free. And then Saturday's the big day. Saturday at noon, we officially dedicate Renfro Hall at noon, right in front of that downtown residence hall. So if you are free, please join in all the festivities and have a great week. And I look forward to seeing everyone next week. Thanks.